my name is Emma Shim, and this is a video on arithmetic and geometric series. Introduction. Arithmetic and geometric series are both the sums of sequences, but as someone might assume, arithmetic series have to do with arithmetic sequences and geometric series have to do with geometric sequences. So, what exactly are arithmetic and geometric sequences exactly? You can skip ahead a couple seconds if you already know. Arithmetic sequences are sequences of numbers which have a common difference. Below is an example of an arithmetic sequence. 2, 4, 6, 8, 10, and so on. Now this is the equation for finding a value in this sequence, or any arithmetic sequence. an equals a1 plus open parentheses n minus 1 close parentheses times d. You might be able to tell the common difference is 2 each time you add 2. And a1 is the starting value, or your first value, which in this case is 2. Geometric sequences are sequences of numbers which have a common ratio. Below is an example of a geometric sequence. 2, 4, 8, 16, 32, and so on. The equation for finding a value in this type of sequence is an equals a1 times r to the power of n minus 1. And I'd just like to note that n here is the number of the value that you're trying to find. Like if I'm trying to find the fifth value, n would be 5. So I would have a5 equals a1 times r to the power 4, since 5 minus 1 is 4. And the same deal is here. So if I were trying to find the fifth value, it would be a5 equals a1 plus 4d, since 5 minus 1, again, is 4. So back to geometric sequences. The common ratio is 2 for this example, and the starting value is also 2. So what is a series? Arithmetic and geometric series are both the sums of sequences or all the values of a sequence added together. Find the sum of the following arithmetic sequence. Add all the values. 2, 4, 6, 8, all the way to 12, 14. The answer is 56. Calculating the sum of a sequence gets very repetitive very quickly. However, there is a much faster way using a formula. The formula for an arithmetic series is Sn equals n, open parentheses, a1 plus an, close parentheses, divided by 2. The formula for a geometric series, is Sn equals a1, open parentheses, 1 minus r to the power of n, close parentheses, divided by open parentheses, 1 minus r, close parentheses. The key is a1 equals the starting value, an equals your last value, and n is the total number of terms that you're dealing with. Let's move on. So what about infinite sequences? Arithmetic and geometric series are both the sums of sequences, as we covered before. However, series can also be the sums of infinite sequences. Infinite sequences are like the one to the right. They don't have a last value and go on forever. However, they do have a starting value and common ratio or difference. So how do you solve for the sum of an infinite sequence? For infinite arithmetic sequences, this is just for infinite arithmetic sequences, the sum is either positive or negative infinity. If the common difference is greater than 0, the sum is positive infinity. If the common difference is less than 0, the sum is negative infinity. Using this information, what is the sum of the infinite arithmetic sequence to the right? The answer is infinity, since 2, which is the common difference, is greater than 0. So what about infinite geometric sequences? For infinite geometric sequences, the sum can be found so long as the common ratio is greater than or equal to -1 and is less than or equal to +1. If the common ratio fits the requirements above, you can use the equation sum equals a1 divided by open parentheses 1 minus r, close parentheses. And you might notice that for infinite infinite geometric sequences, we use sum or S rather than Sn. And in this equation, A1 is your starting value and R is your common ratio. Try solving for the sum of the infinite geometric sequence below. Remember to use the equation to the right. And the sequence is 8, 4, 2, 1, and so on. The answer is 8 divided by 1 minus 1/2, or 16. Thank you so much for watching. I hope you learned something new today.